this is Code and today as usual we're gonna do some Leetcode problems. So welcome everyone, bring anything you can drink. As I said, this is Code and for the new ones, in this channel we do some Leetcode problems every day until I get a job or an internship. So I apologize, yesterday I didn't do a stream because I was a little bit sick, but today I hope we do some good work. So this is my GitHub and this is my YouTube channel. So currently we are 961 subscribers or followers. Hopefully we hit the 1000 sub tomorrow. So don't forget to subscribe to the channel, and you can find all my social media account in the YouTube bio. So this is my LinkedIn, this is my GitHub, this is my Instagram, and recently we did a Discord server, and you're all free to join it anytime you want. So without further ado, let's go to the Leetcode problems. Hey, welcome, brother. Everything's good. So as I said, we're gonna do some Leetcode problems today. So yesterday we did, or the last stream we did a dynamic programming problems, and let's discover. So as I said, the theme of today is the hero path. So, oh no, this is the old one. Okay, this is the old one. Okay, I'm gonna bring the. Okay, let's discover the problem first. So the problems for today are the dynamic programming, but multi-dimensional. I think we're gonna do some list. Hey, Happy New Year, man! Happy New Year to all. I didn't forget it. Happy New Year. So I think today we're gonna do some dynamic programming, but in the multi-dimensional data structure. Like I think we're gonna work with some matrix or 2D arrays. So I think already I did this. Okay, so let's jump to this problem. Let's bring the draw. Okay, so this is the last problem. Okay, let's do it. So given two strings, text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. Okay, so a subsequence string is a new string generated from the original string with some character, can be none, deleted without changing the relative order of the remaining character. Okay, so for example, you have ACE, so it's subsequence of ABCDE. So a common subsequence of two string is subsequence that is common to both strings. Okay, so we have the first string is ABCDE and the second is ACE, and we have the output is 3, so 3 is the length of ACE. Okay, so let's just draw it. So for example, we have this is A, B, C, D, and E, and we have another word. We have another word which is ACE. And we have to return the longest common. So and the second example we have ABC and ABC. So we're gonna return the ABC. Okay, so we have a test case. If text1 equal text2, then we're gonna return the length of any one of them. Okay. And I think we also have like 3 conditions, I think. Okay, so if we have ABC, this is the string 1 and this is the 2 ABC. So if they are like equal, then we're gonna return the length of any one of them, 1 or 2. And or if we have like ABC here and here we have a BCDE, then I think we're gonna return the length of this, so length of 1. So we're gonna check if this string is included in this, and we're gonna return it length, and same thing, but we can change the order. So if we have like A B C D E, so here and here, or we can make it in one condition, like if text 1 is in text 2, or Happy New Year, my man, can you tell me what is your roadmap? Okay, so my roadmap actually now is Leetcode 75. So when you access the Leetcode problems, you're gonna see this roadmap, which is Leetcode 75, which is composed of 75 questions for like the first steps in the Leetcode word. So you have problem divided by data structure and patterns, and there is a video about the patterns. You have to watch it before like solving this to make it easier for you. Yeah, no. And now we're making some, we're solving some dynamic programming problems. Okay, so if you have like the text 1 is in the text 2, or the text 2 in the text 1, then we're gonna return the len of the minimum. So min of len 1 or len 2. The minimum will be the longest one. Okay, so okay, then how we gonna check? Oh. The first approach is to do like 2 for loops, but how are we gonna do it? Okay, so if we iterate through A, B, C, D, A, so he already gave us the approach, which is we're gonna delete characters from the second one. So I think now I'm gonna see which word has the longest length. You know, if I have A, B, C, D, E, so the second word is the subsequence of it, and then I'm gonna iterate through this. If I don't see a okay, I think I get it. Okay, so I think okay, so now we have A, B, C, D, E. Okay, and we have A, C, E. So I think I'm gonna iterate through the longest word. So here we have A, here we have A. We're gonna skip. Here we have B, here we have C. Okay, this is this letter is not the same as this, so we're gonna delete it, and I'm not gonna change the pointer for this. I'm gonna only change for this. Okay, so C, C are equal. I'm not gonna change it. No, I'm gonna change it actually, and we go to the E. D are E and are different. I'm not gonna change anything. I'm going to okay. So I think I got, but I don't know if the approach is good or not. Okay, so let's code a little bit, and then if we have some problems, I'm gonna modify it. Okay, so I'm gonna have 2 strings. I'm gonna make the string 1 in a temporary like variable to check its length, and if it's the max. So okay, I'm gonna check it. Max. Okay, how I'm gonna decide which word I'm gonna iterate. I don't really want to do two if loops. Okay, so first I have to decide like okay, so let's just write it here. put this in. Okay, so what word to iterate? We're gonna choose the longest. Okay, but how are we gonna choose the longest? How to choose the longest? I think, well, we can like make, I'm gonna make two variables. Okay, I'm gonna initialize two variables, which is larger and smaller. Okay, and then compare text1 to text2 and put the longest word in largest and the left and the other in small. Larger, okay, larger. The other is smaller, okay. I'm gonna like choose if, I think. Okay, so then after all that, okay, so I'm gonna iterate through the largest through the larger, okay, and initialize two pointers. One is I for this, and the other is G for this, okay? I for larger and G for smaller. So using a while loop, while I is okay, so I'm gonna make while I is smaller than len of len of larger, okay. While larger, we have two conditions. If larger of I equal smaller of G, then we're gonna adjust I plus plus and G plus plus equal 1 and plus equal 1. If not, A, B, if not, I'm simply gonna iterate just, if not, just I plus equal 1. Okay, so in this test case, if it's, but if they are, okay. So this in the choose, I have to like put greater or equal, because there is no larger word than the other. Okay. And I'll also have counter. Oh no, not counter. And then return the length of larger, because we're gonna define one. Okay. And okay. If no, we're gonna delete this. Or can't we like delete? I think we're gonna delete or like put it in another word, because if we delete and loop, I think we're gonna make an error of index out of range. But okay, so we're gonna I plus 1 and G plus 1, and then okay, we're gonna delete. Hey, what's up, man? Welcome to stream. We're gonna delete the larger of I don't know if we can do it or not. If we cannot, like, we're gonna make it in another word, and then we're gonna return the length of it. Okay, so I'll make all this in like this, and now we start. Okay, so as I said, I'm gonna define two words which are like larger and smaller. And I equals 0 and G equals 0. Okay, or why do I have to delete it? I only have to like count. So if this or this, I don't really have to delete it. I'm simply gonna count. So and we count here plus plus. So count plus equal 1. Okay, so we're gonna initialize count equals 0. Okay, so we're gonna do the while loop while I flange. Oh, I have to compare. Okay. Oh, sliding window. Hey Kay, how are you? Are you good? Sliding window. Oh, I didn't think about ABC. No, I think I cannot do it with the sliding window. Well, this in the Leetcode, we're working on the dynamic programming thing. I really didn't see how we're gonna do it in sliding window, but if you have an idea, you can write in the chat. I'm gonna work it the classic way. So okay, so if text 1 no text 2, then larger equal text 1, smaller equal text 2. Else I'm gonna swap this. But okay, so if it's the same one, so it doesn't matter if they are equal actually. Okay, then put the longest one. Okay, so iterate through the okay, so I'm gonna iterate through the largest. Okay, so none of larger if larger of I equal smaller of I, then we're simply gonna count plus equal 1, and we're gonna make I plus. I'm learning a lot from your stream, man. Like, it's really helping to see yourself in the society and paying attention. Hey, thank you, man. I really appreciate that. Thank you. It's an honor for me to like to to inspire you and motivate you to do more. Okay, so maybe you can check if character is present in the string 1 using for x in text. Is also put in a new list. I think we don't need to like put a new list or like make a new string. We simply gonna count if the number if the letter duplicates in the two words, then simply gonna count +1, and then we're gonna return count. Yeah, I thought of it like making a new string, but why do we have to make a new string and then return its length? We're gonna simply gonna count +1 and return the count. Okay, so if larger else we're gonna iterate I++ is equal 1. Okay, so let's try it. Okay. Okay, string out of index. Okay, so I just wanna print here print and small. Okay, so larger this and smaller this. Okay, everything is good. While I think this is it. Yes, my bad. Didn't read the output statement. Okay, welcome. Okay, so I think the sec no, then of larger. Oh, I see. So I think like we're not. A and then B. I'm only counting like. Okay, so I'm gonna print EG every time. Here. See what is EG. Okay, so 0 0. Okay, so in the first iteration. Okay, so let's put it here. Let's put this here. Okay, so in the first iteration it is 0 0. Okay, and then 1 1. Okay, so this is good. Okay, so 0 0 and then okay, so B it's not C, so we're simply gonna go to C. Okay, so C is not C. We're gonna go C. It is C. It's C. What is going on here? Okay, so if larger of I, I'm gonna count plus A, I'm gonna call plus G plus 1. If it's not, else if it's not, we're gonna only count. Okay, I'm gonna try something here. So, okay, so like if we have the same number, then we're gonna go like this is B and this is C. C is not B. Then we're gonna only increment the I. So this is C. C is C. We're gonna increment both. E is not D. We're only gonna increment this. E is E, and here we have to stop. So I here is 0 1 2 3 4. Okay, 4, and the length is 5. Oh, it's 24 minutes. If larger of high equals smaller of high, what we gonna do? Count, count plus. Okay, so here I'm gonna print larger of I and larger, smaller of G. Okay. Okay, same thing, but okay. So 0 AA, okay, so now I have a better look. So 0 AA, 1 BC, okay, 2 CC, okay, so 2 C, and then 3 D, 1 C. It has to move. 2 C. Why this is always C? It has to like 3 and then 4 and then 4. String index out of range. Like, is it for the G or for the E? Smaller of E. Oh, man. Smaller of I, man. This is, no, man, it is smaller of G, man. I hope this work. Okay, so if this didn't work, so I have to output Y. Okay. So we have here B, BS, and W, and VOZ hash. Okay, so this, not this. So it's gonna simply, what? If it's not equal, then we're only gonna count I. Okay, so I'm gonna go to this. Oh, okay. Or like, this is a big problem, man. I really didn't see this test case. So it's only moving this and yeah. So VOZ is hash. What is like? I think there's something missing. Something is missing. Okay, so P is okay, so let's try another thing. Okay, so A, B, C, D, A, C, E, A. Okay, so what is iterate through the 2 pointers? I for larger and G for smaller. Larger and smaller. Three test cases are good, man. So if it's all the same, it's moving. But he said in order, okay, so you only have a problem of you have a problem of okay, I'm not finding it. Okay, I'm not finding it. I have to find it. Okay, so this and this. These are not equal, then what's we're gonna iterate? Do you have to look like for the P in the whole word? Okay, so if we look to the P, there is no P. Okay. If we find like a P here, what's we're gonna do? We're gonna start to iterate from this. So okay, so we're gonna count +1 and start from this. We don't find AP. Okay, then we're gonna go to the next one, S. We have to start from this position. Okay, so I'm gonna make the position of the last letter in a, okay, so last letter position, I'm gonna make it letter position. I'm gonna make it in 2 loops. It's too big, but I really don't think I'm gonna do it better. So okay, while I is larger, while G, so I'm gonna make 2 loops, while I and while G. Hope this work actually. I really don't know how this is gonna work, but okay. So while I is larger, if we find the same while G is then of smaller. Print if larger equal smaller, then we're gonna count ++. Okay, but if it doesn't, okay, if I'm gonna ++, I'm gonna iterate the I, and we're gonna make, okay, so we're gonna make last letter position equal G. It's not a problem actually. Oh, but if we have to, and then we have to break, I think. We have to count plus, and then we break. Equal 0. So B, so I now is 1, G is 2. Then we go to the S, and then we start. Okay, so I'm gonna break from this loop. G position, count +1, and I +1, and then I'm gonna break. I +1, and then do G. Okay, so either way. Okay, how I'm gonna do it? G have to start like from I. Like G have to start from the last position here. G you have to start from the last position, last letter position. Okay, last letter position. Okay, if we find the same word, we're gonna make it in the last letter position, and we're gonna start from this. I don't think G have to complete, like, we're simply gonna break. We're simply gonna break. Okay, so else if it's not, so P equal, like, if we have like S P. Else not this, else S, and we have to increment G either way, I think. G plus equal 1, and why we are incrementing I either way? What? Why we incrementing I? If it's not, we don't have to increment this. If it's equal, I'm gonna increment I. If it's not, so we incremented. No, okay. I'm really not okay. So this I and this G. So we're gonna iterate first with G. If we find G, then okay. If we find G, if we don't find G, then we're gonna iterate. And if we find it, we're gonna iterate also. Then we're gonna iterate either way. So I think I'm gonna put it here, but not in this. I think I'm gonna make it here. I plus equal 1. When we end with this, with it, like, okay. Okay, so let's organize our. I think this is correct now. Share your Leetcode account. So my. Man, I wish this go. Okay, so my Leetcode account is Black Mido 7. So this is my nickname in League of Legends, if you know it. So I'm currently like 82 problems, 52 medium. Yeah, this is it. Please work. Okay. So, and this we check an S. Okay. And then we found the S. We checked S. Oh, okay. So I think here we have to if we found the S, we're gonna increment it. Okay, so I'm gonna make it here. If we found the S, man, I have to like, wow, brainstorm it again. Okay, so I have like BSWK like N, and here we have RN R like T. Okay, so T B I S O. We're gonna start from this, and I'm gonna iterate every time. If we found a P, G have to start from P, and I have to go plus equal 1. Okay. Okay, so I think this. Output exceeded. Okay, so if we don't find it, like, oh, okay. مرحبا بيك, السلام عليكم. Welcome stream, man. Okay, so if we don't have any, okay, so ECE and DEF. Let's check. G plus equal 1. I plus equal 1. Okay. Okay, same test case. I'm not getting it. So we check it for the S, and we found S here. Okay. Okay, so we found S, and then okay, so G is V, and we found hash. We didn't find the hash. One hash. Okay, so hash O V W F. Oh, we didn't find hash, so we go to the M. Okay. And then why did we go back to the S? Okay, the S. And then we check it to the M. Okay. So I think we're gonna check until we find AW. Okay, so check to the M. We didn't find T. Okay, so we're not gonna find anything until we go to the Y and the F. Okay. Expected 2. Where is the 2? Okay, so here you have S and VWF. Like, there is no VWF. And the first, or they like OX QR. Oh, so it's the QR. No. This is going like to be more complicated than I thought. Okay, so the problem said we're gonna delete, but I didn't like work with the delete thing. Why do I have to work with matrix? No, man, this is fucked up. No, man, this is fucked up, man. Why do I have to work with matrix? Yo, chat. This is fucked up. Like, is the life is going on? Oh, man. No. This is not... Okay, so I'm gonna work it my way, but like it's 44 minutes, so there is no time, so I'm gonna like ask chat to work it on my way. I'm not gonna work it like the matrix, but I'm gonna like I'm gonna see after the solution to know how to work with matrix. Okay, so yes. Okay, so like he told me that we're gonna use a table of like 2D, like 2D array. dpi of I of g represent the length of LCS for the first I character of text 1 and the first g character of text 2. If text I minus 1 equal text g minus 1, then dpi of g equal dpi minus 1 g minus 1 plus 1. Okay, examples then. Give me this example. Okay, so chat, let's just see this example. Okay. Okay, so like he's gonna do the DP programming, the dynamic programming 2D approach. So if text I minus 1 equal text 2 g minus 1, then it's gonna do this iteration. Otherwise, so I'm not getting it when I equals 0 g. Okay, so I'm not getting it, so I'm gonna understand with the example. So if you have like this text 1 equal ABCDE and text 2 equal ACE, so with matrix all zeros. Okay, iteration comparing A text 1 with ACE from text 2. Okay, match A, both text 0 and text 2 0. So I plus 1, no match, but carry over the maximum from left. 1, and then 1, 1, 1, and then no match, carry, match, 2. Oh, okay, I get it. Well, I really I really cannot like make it on my own without knowing like the dynamic programming thing. So he's gonna iterate through the matrix. If there is no match, every time he's gonna see a match, he's gonna increment this value by 1. So like he iterated A, both text 0 and text 1. So this is the matrix. But why did he choose this position which is 1 1? Because it's A minus 1. Okay, so let's just see it. If text dp okay, so he actually began with the range 1. He didn't like begin with the range 0. So this is not the initial position. This is it. Okay, so he found a match. So he wrote 1 and then no match because A, it's only there, no match, 1, no match, 1. And then B, okay, so there is no match. He's gonna continue writing 1 until he's gonna go to the C, and he's gonna compare it with A, no match. So he's gonna write 1. When he found like C, when he matches the C from text 1 with this C, he's gonna increment the 1 by 2. And every time he's gonna go get a match, he's gonna increment the value by 1. And then I think he's gonna return the last value. So 2, D, there is no match, 2, D from text 1. Okay. Or like this for every D1. No match, no match. E, there is a match. 2, there is a match. Oh, E, there is only 1 match. So why did he choose 2? E with a text, so there is no match. He's gonna write 1. There is a match. How this is? Okay, so dpe of G equal dpe minus 1. dpe minus, this is dpe of G, dpe minus 1, dpg, dpe minus 1, and dpg minus 1, which is this? Plus 1. Else dpe equal dpe minus G plus. Okay, I'm not getting it. I'm not like getting it, chat. Use table dp, represent the LCS character. If text equal 1, then he's gonna increment. Why he's comparing minus 1? Why he's not comparing like I and G? Or he's, oh, okay, so he's gonna start from 1. Okay, so dpi of G equal dpi minus 1 G plus. Otherwise, max dpi minus 1 G. So, okay, so if it's not, let's go to this. Okay, so not a match. Not a match. Okay, so no match. Okay, so this have no match. He's gonna compare it with this and this. The max is 1. He's gonna put 1. And then for this, he's gonna compare it with 1 and 2. He's gonna put 2. Okay. And then he's gonna compare with the 2 and the 2. He's gonna go 2. Then he's gonna compare this with this and this. He's gonna go 1. With the 2 and the 1, he's gonna go 2. Oh, and when he find a match, he's gonna increment 3. And then he's gonna return this last element. I think each cell will equal the max between top. Yeah. He's gonna compare the top cell and the left cell, and the max he's gonna write it here. And if he find a match, he's gonna increment plus 1. So this, well, I really don't. Okay, I get the idea of dp I minus 1 G minus 1 plus 1 if he get a match, but if he don't get a match, yeah, but if don't get a match, why he's comparing the left cell and the right cell? I really don't get it why he's doing it. Okay, it's correct, but I don't understand the approach behind it. Okay, so what's the approach behind this? Especially when you don't find a match. Why compare with left cell and upper cell? Okay, the approach behind the solution based on dynamic programming and revolves around breaking the problem into smaller subproblems. That is why we compare the left cell and the upper cell when there is no match. Key idea of the TP table. So TP table represents length of the longest common subsequence of the first I character of text n, and the text means that the current character match, and we can extend ending the previous character by one. Okay. If text one, mean this we cannot extend LCS, so we take the maximum LCS then. Oh, so maximum so far. Okay. By either. Okay. Ignoring the current character text one, move the table. Okay. Representing. Okay, I get it. But it's really depressing because the first 3 test cases and the first 7 test cases, like the first 7 test cases or the 8 test cases are good, but man, it's so depressing, man. But it's alright. Like we're learning new things, so it's all good. Oh, it's about 56 minutes. Okay, I think I'm gonna end this video here. Okay, so let's yeah, I really get, yeah, the approach is very good, but unfortunately I don't really I have to train better on the dynamic programming thing. I really, until now, I don't see that much of difference between the dynamic programming and the normal one, because it's all list and matrix and things. I found that the graphs and the binary tree and things are more interesting than that, but I really don't know why. Okay, so let's just see the other solution if they are if they are different. Okay, so top down. Okay, so I think so same thing here, same thing. Return TP, longest common. Okay, I think this is the same approach. So it's about 57 minutes. Okay. So as I said, the theme of the day for the new ones. The theme of today is the labyrinth decision. So let me just copy it. So the theme of today is the labyrinth decision. We worked on this. No, the unique path I actually did last time. So we work on this, the longest common subsequence, the code of connection. So and tomorrow hopefully we'll do these 2 problems if I'm training on them hard. So for the new ones, prepare yourself to do those 2 dynamic programming Leetcode. It's 58 minutes. This could draw. I think I'm gonna end the stream here. So for the new ones, don't forget to subscribe, and for old ones actually, don't forget to subscribe, or or 916 follower. Hopefully we hit the 1000 follower tomorrow. Thank you all for listening. Thank you all for watching. Hope you like this video. Hope I'm gonna make better videos tomorrow or the upcoming period, because the upcoming period is I have exams, the midterm exams, so it's really stressful for me, but we're all good. Thank you everyone, thank you for watching, thank you for support. I read all your comments, your messages. Thank you everyone, and see you tomorrow. Good night.